So we've got a sketch up here that we're asked to do. They gave us a lot of information, but not everything. So we get to make up the stuff that they don't tell us. So like the end behavior, if they don't tell us, we get to pick whatever we want, creative choice. So when we're plotting these up, we just need to be careful and be paying attention to stuff. So our x-intercepts are happening at -5, 0, 2, and 4, which they didn't write as points just because we were going to run out of space if we did. So -5 is over here. Our x-intercepts are where we're crossing the x-axis. So we have one at -5, one at 0, one at +2, and one at +4. Those are all of our x-intercepts. We have minimums, relative mins, so it'll be valleys at -3, -5, so down here, and at 3, -1 here. And these, again, I just like to label them so I'm aware that I need this to be a minimum, and I need this to be a minimum. So I tend to label them. You don't have to. It's not a math thing. It's just I do it so that I don't forget. We also have a relative maximum at 1, 1, so that's here. So that's a little baby maximum. And then our last piece of information they give us is actually a point we already have up here because it's our y-intercept at 0, 0, which is that guy. Right, I know the purple and blue are awfully similar anyway, but it's right there. So from there, we just get to kind of pick what to do. They don't give us end behavior, so you can pick. But there's, I think, kind of a clearest path is if I do this one, and then we go down to the minimum, and we're going to make a little baby mountain, and we're going to make a little baby valley, and then we're going to go. So you can do it like this. If you want to give yourself a downward arrow, you can do that and bounce it off this way. They didn't give us end behavior, so we don't have which way the arrows go. So you can point them up, you can point one down, you can point both down, however you want to do it. Yes, dear.
Since there's two relative bins, they always be pointed out.
Yeah, I was going to say, I was thinking that as I said it out loud. I would probably put one arrow pointing down since it does say relative min. And instead of having an absolute minimum, technically an absolute minimum is also a relative minimum, so I could see the argument too. But you could put one arrow pointing down. Totally valid. Honestly, if we don't tell you specifically the end behavior, I'm not going to make you try and guess that one of them needs to point down simply because I didn't say absolute. I never will, never, and this is forever, I will never, ever, ever on purpose try and trick you. So if you're looking at going, is she being tricky or is she not? I will never on purpose try and trick you. I do not promise accidental. If it happens accidentally, I try not to fault you for that. But I will never on purpose try and trick you with something. I might point out tricky things, but I'm never on purpose trying to trick you. Okay? So if I don't say it and we have to try and guess it, I wouldn't count it against you if we have both of our arrows pointing up, both of them pointing down. Because we didn't give you end behavior. Okay, then let's look at this bottom one down here, number 2, which I'm going to zoom it in just because it's at the very, very bottom. And I'm going to run out of space if I don't put more down here. And we're looking at starting to do a little bit of solving stuff. So we're asked to solve this 3 times the parentheses that has x plus 12 equals -2x plus 3. What should we do first trying to solve this? Say it louder.
I said multiply.
Yeah, multiply by the 3, distribute. We got to get this guy times both of those. So we're going to take our 3 times x. That's going to give us a 3x. And then we're going to take our 3 times that plus 12. 3 times 12 is 36. And we don't multiply further. When we are distributing, and this is a mistake I see frequently. This is our go, green light. This is our red light, stop sign. So when we are distributing, you stop at your closed parentheses. Do not go past it. I don't care if there's a +7, whatever over here, or if there's even another parenthesis. Your close parentheses, your stop sign. Stop right there. So then we have, I'm just going to bring down everybody else over here. So we have our minus 2x plus 3. Then what should we do? We got rid of our parentheses. Sweet. Oh my God. What should we do next?
Combine like terms.
Combine like terms. Be more specific. Because yes, but how? Add 2x. We want to get our x's on the same side of the equal sign. So if I add 2x to each side, these x's are going to cancel out and go away so that we can get these together. You could also take this 3x and subtract it. Totally valid. There's lots of pathways through this. I do know that we tend to go a little when we have negative numbers with our x. So if you always move the smaller one, you will have the least amount of negative numbers. So if you always move the smaller x, you should wind up with mostly positive numbers. Not going to guarantee forever positives, but it'll give you the least amount of negatives. But that's just a personal preference situation. It is not wrong to take the 3x and move that. But either way, at this point, we should get 5x plus 36 equals 3. Then what? Minus 36 from both sides. Because again, I want to get an x equals. When it says solve, we're trying to get down to an x equals. So if I subtract 36 from both sides, we're going to be left with our 5x right here. Fix that 6 because it looks weird. And then we have 3 minus 36, which is going to give us negative 33. Up to my fraction earlier. There we go. But we want to get to an x. I want x equals. Whenever we say solve, that's what I want. X equals. How do I get x by itself?
Dividing.
Divide by what?
Negative 33 divided by 5.
We're going to divide both sides by 5. Because 5 over 5 cancels out to just be a 1. If I have 5 cookies to split among my 5 friends, everybody gets 1. It's just 1 cookie. So we get our x equals, and negative 33 over 5 does not simplify. So that is that is a totally valid answer, 100% okay. We look at that and we go, ew. But it works. If you want to switch it into decimal form, that's totally okay. That would be negative 6.6. Or you can put it as a mixed number, negative 6 and 6 tenths, 3/5. I do not care if we do it as improper fractions, mixed numbers, or decimals. I don't care. They all work. They mean the same thing. They are equivalent. So whatever works better for your brain, put that on the paper. I will take all 3 answers. Just don't tell me it's negative 7. We're not going to round things unless we specifically tell you to round stuff. Or it makes sense in like a story problem. Okay? Questions on our bell work? Awesome sauce. Oh. All right. Okay, so we have a new notes packet. Ooh, so pretty. It looks like this. Oh, come on. Because this first chapter has so much stuff in it, we've just kind of cut it into 2 parts because there's kind of a nice break in the middle. So we had all of our sketching and our estimating and our kind of the vibe of a graph. And now we're going to start doing like proper graph. Like we gonna graph. So when we are graphing, and I'm going to emphasize this repeatedly, use a pencil. Please use a pencil. because I'm going to draw this up there. This is what we should not be doing. When we draw with pen on a line and we go, sweet, there's my line. Oh, shoot, I made a mistake. I really meant right here. Oh, wait, that's wrong too. I mean this one. I've had papers turned in that look like this. I can't tell what I'm looking at here. I really can't. Use a pencil. I don't care if we do tables, equations, all that stuff in pen because we can cross out and get more paper. The graphs, you don't have extras on the paper. I have plenty of graphs. But like, please use pencil. If you need a pencil, I have pencils. I have them by the box. Like I have tons of pencils. Use a pencil for the graphs. Also, since we are graphing properly, using points and things, you're also going to need a ruler. If it's a line, use ruler. Because even if we are so good at drawing straight lines, I promise you we're not, because this one looks like a straight line. It's not. Which means if I was using this to try and make an estimate or read my graph, these points aren't right. Even though that looks like a straight line. It's close. Use a ruler, use a pencil. I'm very, really strict about writing utensils. Use the pencil for graphing. For graphing, we need it. Promise. Okay. Rant over. Let's math. So we're going to be looking at lines right now. We're going to start by graphing lines. And we are going to start by using a table. So we're given this equation here. X plus 3y minus 6 equals 0, which is admittedly kind of a gross equation. And we are supposed to use this table that they have filled in about 3/4 of it for us to complete our graph. But the first thing I notice is that this equation is rather gross. So they ask us to, looking over here, switch this to be a y equals first. So if we're looking at x plus 3y, let's write it up here, 3y minus 6 equals 0, and we want to set this to be y equals, what do I do to get my y by itself? There's several pathways through. We can subtract x from both sides. Absolutely valid. Minus x, minus x. What else is going to need to move away from the y? The 6. So we can also add 6 to both sides. If you want to do that in 2 separate steps, that is totally okay. If you want to do that in 1 step like I'm doing here, also okay. That's going to leave me with a 3y on this side because my x cancels out over here and my 6 is going to cancel out over here. And it's going to be 0 minus x plus 6, or just minus 1x plus 6. And again, you don't have to put the 1. It is helpful for some people. It is not helpful for others. But now I have 3y. How do I get it to be just y? Divide by 3. I have 3y. I want just one of them, so I need to divide it by 3. If I divide this guy by 3, I also need to divide this guy by 3. And I also need to divide this guy by 3. So the 3 divided by 3 becomes a 1. So we just have our 1y, which is what we were wanting. I have my minus 1x divided by 3, which is minus 1/3 x. And this is one of those times when it does sometimes help to put that 1 there so we notice it. You can absolutely write it as x over 3, but we also need to know that that means the same thing as 1/3 x. Plus 6 divided by 3, that we know is a 2. And we can see that we were right because it's actually right here on the table. Which is also part of the reason we don't use the blanks in the workbook, because they gave us this much space and asked us to do exactly this question. This is a snip from the workbook, and we can see why we don't necessarily use it so much, because they've done 90% of the work for us instead of letting us think. So, and our equation is, our y equals is that negative 1/3 times x plus 2. We can switch the equation around into a form that works better for us. We can also rock on with it in the chaotic form that it's in. And we'll look at those in other forms here in a little bit. But they've taken this table and kind of filled in great chunks of it for us. So they've picked x's for us to use. I'm going to walk you through how they picked those at the end once we fill in our table. And we put our equation, and we're substituting it in. You can type these into the calculator to get them, or we're going to be able to think them through because calculation's not super difficult. But they did the top line for us entirely. We have our -6 that they picked for our x, that they're substituting in place of the letter x, so that we get our -1/3 times -6, and then plus 2, and they gave us our answer of 4. So we're substituting this value in and putting the answer over here. So with our -3, we're taking our whole equation and substituting in that -3 in place of the x. -1/3 times -3 is going to be a +1. +1 plus 2 gives us 3. So that's where they're getting that answer from. This x of 0, they've substituted it in for us. Our -1/3 times 0, what's anything times 0? 0. 0 plus 2, 2. Then we're going to take this x that they picked of 3, they've substituted in here, -1/3 times 3. What is -1/3 times 3? Super close. -1. Then we have -1 plus 2 is going to give us 1. You can also just straight up type these whole statements into the calculator. And I'll show you that on this last one, mostly because my calculator isn't loaded yet because my computer's been in a mood. And our bottom one, same kind of thing. We're going to take our 6 and substitute it in place of the x. So we'll have our -1/3 times 6 and then plus 2. And if you just want to type these in the calculator instead of having to think them, let's clear that out. We can take our second column, third button down, my most favorite button on these yellow calculators, our fraction that looks like a fraction. Put our -1 over 3. There's our -1/3. Substituting in our 6, putting it in parentheses, plus 2. We can put the whole statement in exactly as it's written right there. And we get 0, which is what they have pre-filled in the table because they have done that work for us. Because they're super helpful like that. And that fills in our table. Now, when you're making your own table, you do not necessarily need to have the middle part written right there. You just do your work somewhere or put it in the calculator. That's fine. All we need is the x's and the y's. Because this makes our ordered pairs for us. It tells us our points to plot up. They're in this column and this column. So our ordered pairs are coming in rows. So -6, 4. That's our first point. -6, 4. 1, 2, 3, 4. Our point is going to be here. So this is my x value, this is my y value. So then we're going to have down here on this next row our -3, +3. So -3, 1, 2, 3, +3. And our next one is this 0, 2. So we're right there. Then we have our 3, 1. And one more point, I've got my 6, 0, which is right here. And we can see all these points up here very clearly are connecting up to form a line. So grab your ruler and connect them up. Draw your line. It should look like that. On each end of this line, there is an arrow. Because we are not stopping because my equation doesn't work. We're stopping because I ran out of graph paper. And when we're graphing, I do want you to go from edge to edge on these papers. Go all the way as far as we can. Now, we don't need to be, super sarcastic and go past it through the words. can if you want to. It's your paper, your choice. But the line doesn't stop here. It keeps going. I'm just not drawing off my graph paper. So go to the edges of the graph paper. I never give you gargantuan graphs that you're going to need to like move the ruler and like draw more. But do not tell me that this is your line. That's bad. I can't tell what we're pointing at. The more dots we have, the easier it is to connect them up. But we're just kind of picking x's to find y's. It feels really random that they picked 6, -3, and 3, and -6, and all those things. The reason they picked these random x's like this is because they saw this 1/3 and went, oh, I don't want decimals. So they picked multiples of 3. You could absolutely do this with -2, -1, 0, 1, and 2, which are going to be values we use bunches and bunches this year. You could pick random points and do that. You might wind up with decimals, and that's okay. We can have decimals. But they just picked it so we didn't have so many. That's the only reason they're jumping chaotically like this, is they took multiples of 3, so it was the least amount of fraction possible. Okay? Questions on this one? I feel like this is the longest possible way to do these graphs. So it'll only get shorter from here. We like that. Okay? So table is a fine option. It's just a long way. So we're going to learn a couple of different ways, or remember a couple of different ways to do other graphs. So option 2 is going to talk about using intercepts, using x and y intercepts. We've talked about x and y intercepts. We know some things about x and y intercepts. So if we think about my x-intercept, what do we know about the x-intercept? We know something. When in doubt, think back to this guy. What do we know about our x-intercept points? There's no y. Our y is 0. So x-intercepts, no matter what, our y is 0. That's what goes on the line. I just don't have the lines up here. What do we know about y-intercepts? 0 for the x. So we know that x-intercepts have a y of 0, and I know y-intercepts have an x of 0. I have an equation here. So for my x-intercept, if I want to find it, we know y is 0 as part of the definition of an x-intercept. So I'm going to take my equation, my 3x minus 2y, but instead of the letter y, I'm going to put my 0 in there, because I know for my x-intercept, it has a 0 there. So when I'm working on finding my x-intercept, I'm going to put my 0 in for the y. This is something we can solve now. What is 2 times 0? 0. So we're going to have our 3x minus 0 equals -12. Do I need to have the minus 0 there? Is it doing anything? No. We can just write this as 3x equals -12. How do I figure out what x is? Divide by 3 to both sides. So what is our x going to be? -4. -12 divided by 3 is -4. So our x-intercept is going to happen at -4, 0. Let's switch that -4 to be the purple so we see where it came from. That -4. So -4, 0 is this guy right here. And he'll be green. So that was our x-intercept. Same vibe with the y-intercept. I can substitute in that 0 for my x, because I know that x has to be 0 for my y-intercept. I'm just going to give myself a little bit of a barrier here so we can tell where things are different. So I'm going to take exactly the same equation, my 3 times x, but this time I'm going to put in my 0 for the x so that we can try and solve for our y. So I'm substituting that x that we know in. So it's starting over fresh. So we have to do it twice. But we just said 0 times anything is 0. So I know that this is going to be 0 minus 2y equals negative 12. And again, I don't have to have the 0 there, but it is super important that I have the minus sign there. So if it helps you, put the 0 so that we go, oh yeah, that is a minus 2y, a negative 2y. Do not drop the minus sign just because we don't like it. So this is negative 2y equals negative 12. So what's our y going to equal? 6. Divide both sides by negative 2. Negative 12 divided by negative 2, we get a positive 6. So my y-intercept is going to be at 0, positive 6. And that is this guy up here. Then what we have is I've got 2 points. Technically, we can make a line from 2 points. I'd rather us have more, but when we're doing x and y intercepts, 2 is all we get. So we're going to connect up our 2 dots. We're going to use our rulers. We'll use our tools. And connect them up. I just can't put the ruler on the screen because it thinks it's made of about 5,000 fingers. It gets really chaotic. So we're going to connect them up. And remember that the line doesn't end here. It keeps going in both directions. I just ran out of graph paper. There's arrows on both ends. So we can do this by finding our x and y intercepts. This is writing absolutely every step out fully. There is a shortcut way to do this that I'm going to show you on the next one that involves way less writing, as long as we remember our x and y intercepts. Questions on this one before I go to the next one? Because we're going to do another one using our x and y intercepts. And I'm going to start it out kind of the same way. We know we're going to look for our x-intercept. And our x-intercept happens when our y is 0. So if we think this through and my y is 0, we could absolutely write this whole thing out and substitute in the 0 for y. 5 times 0 is going to be 0, right? So this is the same thing as 4x plus nothing equals negative 20. So if we think about this in terms of I substitute in the 0, this whole chunk is going to be 0. I don't have to write the top 2 lines of what we wrote on the last problem. We can just put the 4x equals minus 20. It's doing the same thing. It's doing the substitution with the 0, just thinking it slightly different. So what I did was I took that 0 in place of the y, and this is called the cover-up method. Covering up this piece. 4x equals negative 20. What is our x going to be here? Divide both sides by negative 4, or by positive 4, excuse me. And we're going to find out that our x-intercept happens at negative 5. So at negative 5, 0 is where we have our x-intercept. A lot less writing this way, but we've got to know what was happening. Okay? So if you want to write it out fully like we did on the first one, 100% okay. If you want to take this shortcut method using the cover-up, totally valid. I'm going to do it again for our y-intercept. Because for our y-intercept, what we know is that our x has to be 0. That's what makes it a y-intercept. If my x is 0, I know 4 times 0 is 0. So that thing's going to go away. We're left with a positive 5y plus 5y is negative 20. So just make sure we're being careful of our signs. Really, this is the time that you're grumpy about that. So our 5y equals minus 20. Just make sure we're paying attention for signs over here. Wash your face. So finding our y-intercept, we can do it that way. Our 5y equals minus 20. And then our steps are very, very similar. I need to get my y by itself, so this time we're going to divide by 5. And our y-intercept is going to be at, where?
Negative 4.
-4. So our y-intercept is at the point 0, -4, which means it's right here. Again, I've got my ruler, got my points, connect them up. Like that. And there's arrows on both ends. Like that. Okay? You can do it either way, whether you substitute in the zeros fully and write out the equation, or you think about it like this with the cover-up method. Totally valid. Questions on using x and y intercepts? 2 more graphs. Very familiar way of graphing. Probably our most familiar way of graphing lines. Because we're going to think about our slope-intercept form. This is the top of page 3, by the way. So we're going to try using slope-intercept form. That's our y equals mx plus b situation. We've seen all these pieces. Should be at the very top of the next page. We've seen these pieces before. It might have been a hot minute, but we've seen them. What does the M stand for? Because M has a meaning. I don't know if we know what it is. This guy. What does he mean? Slope. The M is our slope every single time. What is the B? Our y-intercept. So we know a lot about our y-intercept. We know that our x has to be 0 for our y-intercept. So whatever that number is going to be the number that goes there. So you can put your y-intercept as 0, comma b, whatever our b is. That's going to be our y-intercept. That's going to be where we start. And we use our slope to find our next point. How do we use our slope to find our next point? We have a little phrase that we use. We take our rise over run. I mean, we look at how it's going to go up or to the right. Rise, run, right. So typically it's up and to the right. If anything is negative, one thing changes. We either go down or left. Do not change both or we're right back to positive. So looking at this equation here, we've got this y equals 3/2 x minus 4, which is A under option 3 over here. What is our M? In the specifically in the equation. Because yes, you're right, that is our slope. 3/2. What is our B? -4. Good catch on that. Because it's always mx plus b. So we're looking at what's being added over here, and it's a -4 that's being added. So good catch on that. So our y-intercept is at the point 0, comma, -4. That's where we start. That's where we're going to put our first point. The y-intercept is the first thing we need because I've got to know where to start from in order to figure out how to move. Because the slope just tells us how to move. So we've got to figure out where we're going to start first. Cool. How do I move with a slope of 3/2? Up 3, right 2. So I'm going to go from my intercept, I'm going to go up 1, 2, 3, right 1, 2. So here's my next point. And then I can do it again. I can go up 1, 2, 3, right 2. Get another point. I can do it again. I can go up 1, 2, 3, right 2. The more points you have, the easier it is to line up your line. If I just have 2 points, especially when they're really close together, it's really hard to get things lined up properly without it being kind of like super wobbly like this. So the more points we have, the easier it is to get a very accurate line. So I encourage you to go as far as we can on dots because it is way easier to connect them up. So the more points we have, the easier it is to connect our lines and do it well. And just like our other lines, this continues on in both directions. So arrows on both ends. Because my line didn't stop, I just ran out of graph paper. My line keeps going. Questions on this one? One more. Last one. For the day. For the week. Very similar vibe. We're going to do slope-intercept form to get this plotted up. So looking at our equation up here, we've got y equals negative 4x plus 2. What's our m? Negative 4. Good. What's our b? Positive 2. So our intercept is happening at the point 0, 2. That's where we start. Our y-intercept is the first piece we need to have. Because I need to know my first point before I can try to move anywhere. How do I move with a slope of negative 4? Down 4. 1, 2, 3, 4. Over 1. Remember the whole numbers always kind of have an invisible over 1. We don't typically write it, but it's there. So if we go down 4 over 1. So you can write it like this. If this helps you, then you can also see that this says our rise. We need to go up negative 4, also known as down 4, right 1. And again, I can do another point. I can go down 4 over 1. I could go up 4, left 1. As long as I switch one of my directions, we're good. And it's still on that same line. So connect them up. Put your arrows, and that's our lines. I got 3 minutes, don't you back up yet. Okay, so I'm putting up here the reminder to turn in your bell work page. And as another reminder, don't forget about the challenge problem. That last box on the back side of the bell work page is the only extra credit I offer. Challenge problem in the very subtle back corner. Rainbow blinky lights? Yeah, that would be it. Super subtle. And you'll know me almost 2 weeks now. You can tell I'm known for my subtle. Very, very much. People think Mrs. Fiashki, they think it's just so subtle, quiet. Just a cat. So.
See you on Monday.
Huh?
I get to see you on Monday.
Yep. Alright, so this is homework 4. It is not due until Tuesday. You can do a majority of the front page. Cannot do question number 19 yet. You can do everything else on the front. And you can do the review on the back. But question 19, 20, 27, 31 is what we're going to talk about on Monday. So anything that's an equal sign we can do. Anything that has a inequality, less than or greater than, that's what we're talking about on Monday. So that will leave you with 4 problems for Monday. That's not too bad. Okay. Our second quiz for chapter 1 is going to be August 27th. So that is not next Friday, but the Friday after. Nope, the Wednesday after. Excuse me. So don't forget about our Canvas assignments. Those are always up on the Canvas page. There's one every week. Have a great weekend. Let me know if you have any questions on stuff. But that's kind of the vibe.